Right, good morning, everyone. Welcome to the STEM Digital School. This is grade 6, Natural Sciences and Technology. Okay, guys, we are going to continue where we left off yesterday. We were looking at energy and change, and we're busy with electric circuits. Right, so guys, just a few ground rules. Remember to keep your videos off throughout the lesson. You can raise your hand if you want to give me an answer or ask a question. Then I will unmute your mic, or you can use the group chats to send through your questions and answers, right? Okay, so let us just recap. Okay, so yesterday we just started off with electric circuits and we looked at electricity. And we also mentioned that electricity is the flow of current, right? And we spoke about basically the importance of electricity in our lives, etc. So let me just quickly see here. Yes. And we also looked at like charges as well as unlike charges. And we established that unlike charges attract and like charges repel. Right. So I see you guys, I see you in the group, and I am well. I hope you guys are all well. All right. Okay, I see a hand here. Before I continue.
Good morning, ma'am.
Good morning, Kia.
How are you, ma'am?
I'm good, thanks. Yourself?
Yes, yesterday you said I could explain electric circuits today.
Oh, okay. So, yesterday you wanted to explain electric circuits.
Yes, I wanted to explain what things use electric circuits.
Okay. So before I step into circuits, then I'll give you a chance, ne? Before I
Okay, ma'am.
then I'll give you a chance. Thank you for reminding me, ne?
Thank you, ma'am.
All right. Okay, so Kia says yesterday they wanted to explain electric circuits, what we find in electric circuits, and I will give Kia a chance just before I get into electric circuits. Okay, so we left off on this slide, all right? So if you were making notes, this is the place where we left off yesterday. Okay, so I'm just gonna go through it again and then move on to the next slide and then give Kia a chance to explain to us what electric circuits are. Okay, so electric charge, né? The wires in a circuit are made of metal. Metal wires have charges that can move. Charges can all be made to move in the same direction through a piece of wire. We say that the electric charge flows through the wire. Then when electric charge flows through a wire, we say that there is electric current in the wire. Okay, so it's very much important to note this word, which is electric current. Okay, then the wire pathway through which the charges move is called an electric circuit. So, which brings us also to the circuits that we will look at in the next slide, and we'll also give Gia a chance. Okay, so let's continue. All right, sorry guys, are you guys done with taking notes on this slide? Are you guys done taking notes on the slide? You can just use that yes or no button. Quick response. Okay, so Jocelyn's okay. All right, no problem. I'll give you guys a few more minutes. So here, just get prepared. After the next slide, you will be going on. Okay, so Mukona and Jocelyn, just indicate for me when you guys are done. Yeah, just indicate for me when you guys are done, so that I may know if I should move on or not. Guys, video is off. Sive, your video is on. Sive, your video is on. Please switch it off. and Bandile, please switch off your videos. Bandile and Sive Hanisi, please switch off your videos. Okay, so we can move on. I see the no is taken down. Mokona, I just need a response from you, please. Let's says, ma'am, where are the exams? Are you asking about the tests that you guys are supposed to download? Let's just explain to me further. Okay, so you need to go onto the website, right? You need to go on africateamgeeks.co.za and just go under the digital school, and then you will get the assignments there. There will be a link for the assignments, right? So remember, the natural science and technology assignment will be up on Thursday. Okay, right, awesome. Okay, so now because the wire is already full of charges, all they need to do is basically make the move. And what we need for the charges to move is energy. So remember, guys, we have already established that energy, it is the ability to do work, right? So energy is required to make the charges which are found in the wire to move, okay? So they get this energy from a cell or a battery of cells, right? And I know that some of us just confuse cell and battery. And so guys, remember, a battery is a number of cells joined together, okay? So a cell, that is the source of electricity, example, which is used in a torch, is used in a torch, and then a battery, that is a number of electric cells joined together. All right, so here we have the difference. So this is a cell, this is indicating to us a cell, and that is a battery, okay? And a cell or a battery always has a positive as well as a negative end. Very important to note that a cell always has a positive or negative end. Okay, so guys, can I move on from this slide? Just indicate to me, use the yes or the no button. Yeah, I see a yes. Does anyone want? Okay, cool, no problem. So guys, I hope you are taking notes or underlining in your textbook, right? Or just adding on to what your textbook has, etc. Right? Okay, do we have anyone who is new, who's joining us today? Is there anyone who is new, who's joining us for the first time? Okay, I see Kia says yes. Who is it, Kia? Sive and Shumo. Sive and Bandile. Okay, Sive and Bandile, welcome. Guys, now when we join in class, videos need to be off. Right. Okay, Noma Temba, welcome to you as well. Remember, in all your classes, videos need to be off. And guys, we are looking at energy and change. All right. So we're doing energy and change, just in case you are maybe confused as to what are we doing. We're doing energy and change. That is term please work. So you can just turn on in your textbooks by energy and change, and go to the first topic, which is electric circuits. Okay. Right, so Jocelyn, just indicate to me when you are done, right? All right, beautiful. Okay, so this is the picture I was talking about where we say that it's showing us a cell, right, versus a battery. All right. Okay, so this is the difference between the two. And remember, the important thing here is that a battery or a cell has a positive as well as a negative end. Okay. Positive as well as a negative end. Okay, circuits. All right, so just before we get into circuits, let's hear what Kia can tell us about circuits. Just before I give you guys anything on circuits, Kia wanted to share with us what, all right, there you go. Kia, talk to us. Teach us about circuits.
Ma'am. Yes.
Okay, just hold on. Hold on, Kia. Let's wait for your network to stabilize. All right, I think now it's okay. Yes, can take it away.
Okay, we use electric circuits in our lives every day to solve problems and satisfy needs that require energy. Examples of electric circuits, things that use electric circuits is traffic lights. Traffic lights use electric circuits to produce light energy to stop traffic jams and help pedestrians cross roads safely. And then street lights. Street lights use electric circuits to produce light energy to make it safer to walk and drive at night.
All right, just hold on, Kia.
Alarms use
Yeah. Just hold on. I just want to quickly reiterate what you just said right now, because I'm not sure if everyone can hear you clearly. So guys, what Kia just read right now is that electric circuits are used in everyday life. Okay, so she also mentioned that electric circuits are used in traffic lights in order to control traffic, right? And yeah, okay. So Kia, just continue reading. Let me hear.
Okay, ma'am. Alarms use electric circuits to produce sound energy to help us protect our homes and cars. Electric gates use electric circuits to produce movement energy to make it easier to keep intruders out of a property. Fans use electric circuits to produce movement energy to keep the air cool in hot. Heaters use electric circuits to produce heat energy to keep us warmer in winter.
Okay, yeah, just hold on. Because I see here they're saying that you're glitching, right? So the network is kind of unstable. Let me just tell them what you just said, right? So Kia just gave examples, right, of where electric circuits are used. Kia just read that electric circuits are used in gates and they produce movement, right? And alarm systems, right, which produce sound. And then circuits are also used in heaters, I think. Was that the last thing that you read there? I'm saying the last part that you read, did you say that electric circuits are used in heaters to produce heat energy?
Yes, heat energy to keep us warm in winter.
All right, okay.
And electric circuits can also be used in toys and motors to produce energy.
All right. Thank you very much for sharing, Kia. We appreciate that. So I hope everyone.
Thank you, ma'am.
Awesome. Hope everyone could hear what Kia said. And if you couldn't hear, then I think I did explain, or rather just reiterated what Kia said. Okay. You see there's a lot of chats in the group chat. What's going on, guys? What's going on? All right. Okay. Just hope someone will explain what you guys are like. Okay. Anyways, let's get back to the work now. Your next subheading is circuits. So if you are writing down, just write another subheading, which is circuits. Okay, circuits. And let's get into the business of circuits. Right. So all electric circuits have three basic parts, right? Important. All electric circuits have three basic parts. And the first one is a source of electrical energy, which, for example, is cells or a battery. Then, secondly, all electrical circuits have conducting material. So conducting material might be the wire, okay? So as you guys have seen on the previous slide, we dealt with wires, okay? Then thirdly, a device that transfers the energy for a useful purpose. So an example would be the bulb, which would provide light. Another example that Kia gave us was an alarm, right, which provides sound, okay? And then all the parts need to be connected by wires. So these wires is the conducting material. So wires in an electric circuit are called conducting wires. And finally, if any of the conducting wires in a circuit is disconnected, then no charge will be able to flow and the circuit will not work. Okay. So if any of the conducting wires in a circuit is disconnected, then no charges will be able to flow and the circuit will not work. All right, so I believe you guys just need a few minutes to write this down, but if you are done, or if I can move on, just, you know what to do, miss. The yes button on participants, or you can type it in the group chat. So guys, remember, if you do have any questions, you can raise your hand or type it in the group. Guys, you still need time, or can I move on? All right, okay, cool. So remember, the three basic parts of an electric circuit are the source of the electrical energy, the conducting material, as well as a device that will transfer the energy for a useful purpose. Okay. Okay, so Jocelyn, just indicate to me when you're done. I think I saw a hand, someone, okay, probably was a mistake. Yeah, Sikia in the group says traffic lights use electric circuits to produce light energy to stop traffic jams and help pedestrians cross roads safely. All right. Okay, so this is just a continuation or just another way to explain what we have just written down. Okay, so it says the parts, or rather this topic says electrical components. It says the parts that make up an electrical circuit are known as electrical components. Okay, components like a cell or a battery that makes charge move, these are known as input devices. All right, so remember we said that in order, there are three basic parts of an electric circuit, and the first one is a source of energy, and this source of energy is known as an input device. So you guys can just write next to this bullet here, next to number 1, that this is called the input device. All right, input device. All right, so this is where everything begins. This is the start of the circuit. All right, then components like switches that control the flow of charge inside a circuit. And these are known as process devices because they change the current in some way. So we also have what we call process devices. And then we have components like bulbs, buzzers, or motors. These change the electrical energy into useful energy. These are known as output devices because they are components that use the electrical energy to do something. Okay, and the conducting wires that join the other components together into the circuit. All right, so this is just basically explaining more what we have covered in the previous slide. Okay, so I'm just going to give you guys a few minutes just to add on to what you guys have and just also follow in your textbooks. Okay. All right, I see another example. Street lights use electric circuits to produce light energy to make it safer to walk and drive at night. Okay, so Tukelos is all right while you explaining. Okay. Guys, I don't think you answered me in the group chat. I posted a question in the group chat and I would like answers, please. Okay, so guys, can I move on? You can see a yes from Shakira. Okay. Okay, so Tukelo, I see your hand is going up and down. That's up. Okay, there we go.
Ma'am,
Yes,
I
Tukelo.
an answer to your question that do you guys want to build an electric circuit at home?
All right.
Yes, ma'am, we do.
Okay, okay. Thank you very much for that.
You're welcome, ma'am.
Oh yeah, for sure. I'll give you guys the activity tomorrow. Then we'll just look at the circuits next week, Monday. So just yeah, tomorrow or Thursday, I'll give you guys the activity. Then you'll have the weekend to build the electric circuits. Then we can just look at each other's electric circuits in class. Okay. All right. As I move on, because I don't see anyone saying that they need me to stay on the slide. All right. So here we have an example of a simple circuit. So this might be rather something that you guys would also have to build. All right. So we have a light bulb here, and we also have the source of energy, which is a cell here. All right. We also have another example on the right, where we have our light bulb, and we also have our cell or battery. Okay. So again, guys, remember what I said, very important, that a cell always has a positive and a negative end, right? Should always note that a cell has a positive as well as a negative end. Okay, so quick question. Will the light bulb glow if it is connected like this? Will the light bulb glow if it is connected like this? Okay, I see Jocelyn says yes. Nomatamba says no. No, no. Shakira, yeah. Okay, so guys, give me a reason for your answers. So in this case, now guys, for this question, can we just like raise our hands so that when you give me an answer, then you can just someone give me a reason as to why you're saying that it will glow or it will not glow. Okay, Nomatamba.
Ma'am, because the other wire is not connected to the globe.
Okay, so the other wire is not connected to the globe, so the light bulb will not glow.
Yes, ma'am.
All right, beautiful. Thank you very much. Okay, so guys, remember, we said that our circuit needs to be a closed circuit. All right, so if we're talking about a closed circuit, we're talking about everything in the circuit being connected. So if we have this case scenario here, which is appearing on screen, and then this is not a closed circuit and the light bulb will not glow. Okay, all right. Next picture, will this light bulb glow? You guys can raise your hand and give us a reason as to why it will not glow. Okay, see there. Okay, see there, you need to, okay, there we go.
No, ma'am, because there's not another wire connected to the globe.
All right, so it will not glow because we do not have another wire connected to the globe. Thank you very much, Sive. Okay, so guys, again, remember, in your cell, all ends, both the positive as well as the negative ends, need to be connected in the circuit. All right, so all ends of the cell need to be connected in the circuit, both the negative as well as the positive end of the cell. All right, next picture. Will the bulb glow in this circuit? Right, Malu?
Yes, ma'am, it will, ma'am.
Okay, why will it glow?
Ma'am, because both wires are connected to the battery.
All right, beautiful. Thank you very much, Malu. All right, there we go. Okay, yeah, I see you keeping your hand up. All right, I'll give you the last one. Okay, so indeed, guys, in this picture, the bulb will glow. All right, so both ends of the battery or the cell are connected to the base of the light bulb. So the base of the light bulb is this part here at the bottom. All right, so that's where we need all our conductive wire to be. Okay. Then next picture, will the bulb glow? Hello. Okay. Hello. Ooh, hello. I can see you're talking, but then there's no sound coming through. Try again. All right. No, we can't hear you, Kamo. Sorry. Okay, but you can type it in the group chat, ne? Unfortunately, you can't hear. Let me take the next hand. Okay, let's hear Mukona. Okay, Mukona disappeared. Yeah.
Thank you, ma'am.
All right, so will this light bulb glow? Yes or no?
No, don't glow because the negative and positive wires have to be connected at the bottom of the tube for the energy to go into the bulb and make light.
All right, thank you very much, Kia.
Thank you,
Okay, so
ma'am.
if you guys couldn't hear what Kia said, Kia says both the wires need to be connected at the base or at the bottom of the light bulb, and hence this light bulb will not glow. Okay. All right, so let's see. Everyone is following, right? The wire needs to be connected at the bottom of the light bulb. That was Shakira. Yep, that is correct. Okay. No, because it's touching the glass and not the bottom of the globe, right? Okay. Moreover, I see that you wrote that you don't understand. What is it that you don't understand? Just clarify for me there. Okay, so now we are moving on to switches. Okay, so remember we said that switches are also called process devices in a circuit. Okay, so let's see the information that we have on switches. Okay, Mokona, I see your hand is up. Okay, all right, cool. Right, so if there is a break or a gap in a circuit, the charges will not be able to flow. Okay, so remember we said that our electric circuit should always be closed. Okay, and then the purpose of a switch in a circuit is to stop the flow of electric charge through the circuit. An example is the lights in your rooms, guys. You know, when you switch on the switch, right, the light bulb turns on, but when it's off, then the light bulb goes off. That means that there is a break or a gap in the circuit. Okay. So then when the switch is off, the charges cannot flow, so the whole circuit is off. All right, but that doesn't mean that there are no charges. It just simply means that they cannot flow, but the charges are still there. All right. Then when you close a circuit by switching the switch on, it's like connecting two wires together so that the charges can flow again. But in the previous examples that we looked at, we didn't have a switch, so there was continuous flow of charge. Okay. So in the previous examples that we looked at, we had a continuous flow of charge, but the moment we put in a switch, then we can control the charge. All right. So guys, can I move on from this slide? All right, cool. No problem. I'll give you guys 2 minutes, then we will move on. So do you guys have a section in your textbooks which speaks about switches? You guys have a section in your textbooks which speaks about switches? All right, okay. Okay, so does anyone want to read to us what their textbook or the notes that they have in front of them say about switches? Anyone? Anyone? Nobody? You can raise your hand if you want to share what your textbook says about switches. All right, I see here your hand is up.
Thank you, ma'am. Can you hear me nicely?
It's still glitching, but let's just stand a bit far back from your mic. All right, let's hear.
Can you hear me much better, ma'am?
I can hear you. I can hear you, but it's not nicely. I'll just explain what you're reading there. So just after every 2 sentences, stop so that I can explain to the class. Okay.
Okay, ma'am. Switch is the touch has a switch. When you switch the touch on the electricity starts to flow along the torch circuits. When you
Alright.
switch the torch off, the electricity stops flowing.
Okay, so what Gia just read is that on a torch, when you switch the switch on, then the electricity starts to flow and then the torch lights up. When it is off, then electricity does not flow, meaning that the light will not be on. Okay.
The switch controls the flow of electricity. When the switch is turned off, it stops the flow of electricity through the circuits.
All right, so when the switch is turned on or off, it controls the flow of electricity, right? So guys, very important to note that the switch, it controls the flow of electricity or it controls the flow of charge. All right, thank you very much, Kia. Okay, awesome. All right, cool. Okay, Talia. Talia, your hand was up. You want to
Yes,
share?
I wanted to read what my textbook says about switch.
All right, cool. Take it away.
Okay. Electricity is not able to move through the circuit if it is broken in any way. A switch can be added to a circuit. We use an electric switch to start or stop the flow of an electric current in a circuit. When you use a switch, you can control the movement of electricity in a circuit. This is useful for when you want to turn an appliance on or off without having to plug it in or to unplug it. All electric appliances have switches. The photograph, oh, never mind.
Okay, thank you very much, Talia. So what you guys might have noticed is that Talia's textbook speaks about electric current, and Iya's textbook spoke about electricity. So guys, remember we said that in a circuit, we refer to the electricity as current. Okay, so other textbooks might say charge. All right, so this word current, electric current, electricity, as well as charge refers to the same thing. Okay, so don't get confused there with the slides that I might have and the terminology I use, as well as the terminology that is being used in your various textbooks. Okay. All right, let us move on. Thank you, Jocelyn, for that. Okay, so here we have an example of an electric circuit. We have our battery, we have our wire, which is indicated by this black line. We have our switch, and we also have our light bulb, which is on, okay, because the switch is also on, okay. So here is a simple electric circuit diagram, right? So this picture here is basically also the same picture here, right? But in this case, we have, or rather we are using symbols, which is leading us to circuit diagrams, which is our next topic. But yeah, which is our next topic. So let us see what we have learned so far is that an electric circuit needs to be closed, otherwise charges will not flow, right? Then we said that this means that there must be a continuous path for charges to flow, or for electricity to flow, or for electric current to flow. Okay, so if there is a break in the circuit, the charges will not flow. A switch controls the current. It can switch the current on or off. A simple circuit will work no matter where the switch is placed. Okay, so this is what we have covered so far from yesterday and today's work. So you guys don't need to write this down. We have already written it. Okay. All right, I see we have 5 minutes left and we need to get into circuit diagrams. So unfortunately, we won't have enough time to basically look at everything. So I'll just end the lesson there. Okay, so we'll continue tomorrow from where we left off. Okay, guys, tomorrow we will be looking at, We'll be looking at electric conductors and insulators. So that's where we're going to start off. And then, guys, with regards to textbooks, if you guys do not have any textbooks at home, you can go on Snaplify and you can get yourself the Via Africa textbook, or you can go on the website that is shown on screen to get the Siavula textbook. Okay. And so these are the two textbooks that I used for the lesson. And guys, thank you very, very much for joining in today's lesson, waking up early, coming to natural sciences. Guys, if you do have any questions, you can email the school at stemdigitalschool@africateenkicks.co.za, or you can drop me an email if you need the slides. Okay, guys, all the best with your assignment today or your test. Not sure which subject you're writing, but also enjoy your day and enjoy all the classes that follow. Goodbye, guys. Bye. Bye, Tukello. God bless you too.